All right, 6-5, properties of logarithms. I think this is 6-5 here. And they give you some here where this one, if you have two, you're doing a log of a base and two things multiplied. So it's a product or a sum, the sides of a sum of two separate logs, and this is where they were a log of a product. Similarly, but almost like inversely, and instead of multiplying, if it's dividing, then it's subtraction. So that seems to go together. If multiplying is addition of two separate logs, dividing would be subtraction. It has to do with your exponents. You know, if you had 10 to the 5th over 10 to the 2nd, you subtract these exponents, right? That's a fraction. And if I had 10 to the 5th times 10 to the 2nd, you add these. So this is a product and you add them. So that's where it really comes from. And then the last one is where this n, the exponent property, power property exponent comes out in front as a coefficient. So those are the properties we're going to work with. There's one other really pretty important one called the change of base, but with technology today, I don't know if it's near as important as it used to be. So this is just showing you where it comes from or how. And again, see this multiplying here, then you would add the exponents, right? And so then if you change this into a log, you can prove that that's what it comes out to. So so if they wanted you to expand this one out, so remember, this is a product right here, right? So then applying that property we were just talking about, log base 5 of the first one, a squared, plus log base 5 of the second term of the product, b to the 7th. And then they also want you to keep going and use your exponent or power property here as well, where that comes out in front of the log. So your final answer here would look like this. Okay, so exponent properties, sometimes it's just a good thing to keep a set of notes. For me anyway, I would let you use those on an exam. Expand this one out with your properties. So remember what it just said? We said we take the log of the numerator minus the log, and in this case, natural log of the denominator. That's all. Combine these back together into a single log. So the first thing, take this out here, put it up in your exponent, power exponent rule on each of those. So I've got log base 4 of m to the 4th plus log base 4 of this n to the 3rd. That coefficient goes up in the exponent. And then my minus log base 4 of my p. All right, now I would take these two together first to write a product on those. So it's log base 4, because they're adding. So remember, that would be these two multiplied together like that. And then we saw this minus log base 4 of p. And then remember what that means. When you're subtracting two log, that can go together as a fraction. So it'd be the m to the 4th, n to the 3rd, all over this p for the final answer. All right, putting this one as a single log. It's the same as the last problem, just almost, this one's actually easier, I think, because it's just natural log, but don't let that mess you up. So this is natural log of 2 to the 3rd minus natural log of 5 to the 2nd. Then when you have two logs that are the same base with subtraction, to put them together when it's subtraction, it's just a fraction or quotient. All right, and an application problem. So the pH, You know what that, the acidity thing of something can be calculated as if you're talking about the concentration of hydrogen ions in the moles. So 1 over the number of hydrogen atoms in the mole. So if they tell us acid rain has a pH of 4.5, so that's my answer over here on the left. And we're supposed to be finding the concentration of hydrogen ions. So what's my base here if nothing's written? Whenever your variable's in this expression, that means write an exponent problem. So this is base 10 to my power. But that's 1 over the concentration of the hydrogen ions. So we're going to have to still get that out of the denominator. So what we would have to do first, and I'm going to work out that 10 to the 4.5, but I would first multiply by this to get it out of the denominator. And then, once that's out of there, then I'm going to divide by the 10 to the 4.5 to solve for the concentration. So that's going to be 1 over 10 to the 4.5, or I don't know if you really want to work that out or not, but if you do, go ahead. And that's it. The change of base property, again, it's something that I just like to point out because a lot of places use it. But if you have a calculator technology that can do this work for you, before that existed, a lot of calculators had base 10s, so they needed this to do on calculators, but usually you don't need to with today's technology, but just something to point out the change of base property in case you're expected to have had experience with it. So this problem, variables in the exponent, log base 2 of 7 equals x. That's all you need to do. To do it with the change of base, that's the log, and I remember it as the 7's up higher, so log base 10 of 7 over log base 10 of this 2 because it's down low, and then you can just do that in the calculator. But again, with a normal calculator today, you can enter the original log base 2 of 7 in without even needing to do this step over here. And that's all we've got for 6-5.